Okay, so when we set up a unit conversion, here's our T-chart. We cancel our units diagonally. Always what we want is going to end up usually in that top right-hand corner of our chart, right? I want to get it to inches, and that's what's going to sit there, okay? So let's go, let's try another one here. 4.5 pounds to grams. Now, do you see an issue here? Pounds and grams, what's the problem?
Two different systems.
Two different systems. One's metric system, one's not. Have I given you these charts yet?
Not the names.
Okay, they are in your notes, but I also have a big copy of them here for you to have, so you don't have to be flipping back and forth in your notes all the time, okay? So these are things you might just want to keep out while we're doing these conversions. Can you pass them back? I'm afraid I'm going to be short because I handed one out to someone else earlier that was missing theirs. Ooh, okay, let me print two more for you guys. For right now, they're in your notes, but I'll print two more, okay? Luke and Josh, or somebody, okay. So I'm going to go from pounds to grams. I don't have a one-step conversion for that, do I? Look on your conversion chart. One of them is metric system, one of them is US to metric. Do you have any single step in your conversion chart that tells you how many pounds are in a gram or grams are in a pound? No. Did it tell you that?
No.
So how can I switch over from the US system to the metric system? Okay, it goes to kilograms. So very good. So my path is going to be pounds to kilograms and then kilograms to gram. Okay, because we're going to be able to do that. We're going to be able to convert from kilograms to grams using the metric side of our chart. Okay, would we agree with that? Mm-hmm. Okay, so let's go ahead and draw our T here. I'm going to start with, what did I say I was going to say? Start with what we know. Start with what we know. The chart always starts with what we know, which is 4.5 pounds. And I draw my T. We said we're going to go from pounds to kilograms. That's the only kind of natural progression for us is pounds to kilograms. And then we're going to go kilograms to grams. So you can either put the numbers in as you go, or you can wait and do that afterward. That's completely up to you. Okay, but what we want to do now is go through and make those columns of our chart true. We don't do any math until the very end. Okay, so now I'm going to look here and say, which one, what's my chart tell me about pounds and kilograms? What's it say?
2.2 pounds.
So 1 kilogram equals 2.2 pounds. Okay, I will say I like to usually give the larger unit the 1. Does that make sense? I like to give the bigger unit the 1, and then I say how many of the little thing are contained in that big thing. Okay, so I don't like to have decimals or fractions go into my chart if I can help it. Okay? And then I'm going to look at kilograms to grams. So between kilograms and grams, which is the bigger unit? Kilograms is bigger. Kilograms is bigger, and in a kilogram are 1,000 grams. Do you see that on your metric system chart? So this is the back side of your chart now. You're looking at where it says 1 kilo unit equals 1,000 units. And we see that applies to every type of system. Are we ringing bells with that?
Yeah.
Okay, so if I asked you, for example, how many liters were in a kiloliter, what would you say? If I said how many liters are in a kiloliter, you would say 1,000, right? It applies to grams and meters and liters and seconds and whatever you want to, okay? So now that I've got my chart all set in, I'm going to check my units one final time. Pounds canceled, kilograms canceled. I'm left with grams, which is what I want. And then I multiply across the whole top, divide by the whole bottom. So I don't need to multiply. I'm going to take 4.5 times 1,000, then divide by 2.2, and I get a value of 2,045.5 grams. Do we feel like that answer seems reasonable? It seems like it's going to fit within our window of what we were thinking. Mm-hmm. I would agree, right? If we would have gotten a fraction of a gram, I think that would have been a red flag, right? And too big of a number could have been a red flag because it was only 4 pounds, so we started with 4.5 pounds. How do we feel about the T-chart system? Is that pretty similar to how you learned it in math? Yeah. Very good. Yep. Let's see, do we have more examples on our next slide? Okay, yep, let's do a couple of these ones. These are pure metric system, so it's going to use the same principles, but these are all within the metric system, okay? Are these ones printed for you? Okay. How many centimeters are in 0.48 kilometers? So can you go directly from kilometers to centimeters? Do I know exactly off the top of my head how many centimeters are in a kilometer? No. But what's my middleman between those two things? Good. So I'm going to go kilometers to meters to centimeters. Does everyone feel okay about how we determine the middleman there?
Wait, is it kilometers?
Kilometers. KM. Yep. Kilometers. K is the prefix for kilo. That's the unit meters. Okay? So the simple unit for length is meters. Kilo means it's a lot of them. Centi means it's a small portion of them. Okay? So let's start with what we know. 0.48 kilometers. We get rid of kilometers and go to meters. Get rid of meters and go to centimeters. If we were just expecting our answer here, would we expect it to be big or small?
Big.
Big, right? We're going from kilometers to teeny tiny centimeters. So it's going to be pretty big. Okay? Here I'm going to say is it going to be like this? 1 meter is 1,000 kilometers? No. Yeah, that's a really common mistake because I always say kilo means 1,000. That's true, but it's 1,000 of the little guy. So 1 kilo is 1,000 of the little guy. And then 1 meter is how many centimeters? Good. What's cent? Right. What's cent mean? Yeah, century, cents, and a dollar, right? That prefix should tell you 100. Okay? So I'm going to multiply across. 0.48 times 1,000 times 100 gives me 48,000. Now, have you guys learned the just move the decimal place kind of pattern with this too? You could do that as well. I'm completely fine with you doing that as well. Okay? So here, I knew I was going to move it 3 places to get to meters, and then 2 more places to get to centimeters. So let's look at that again. I would move it 3 places, kilos 1,000. Then I would move it 2 more places for centi, so it ends up just the same, 48,000. I'm fine if you do that as well. Okay? Let's try the next one. Kilometers to nanometers. Kilometers to nanometers. What's our middleman got to be again? Has to be meters. And then we're going to go nanometers. Okay? Nanometers is a little tricky because it's a really, really teeny tiny unit. Okay, so let's see what this is going to look like. 4.24 kilometers. Kilometers to meters and meters to nanometers. All right, so it's going to be real big. Okay, so a kilometer is 1,000 meters. 1 meter is 1 times 10 to the 9th nanometers. Do we see that on our chart? So that would follow. That would be that you have 9 zeros following that 1. So it would be like a billion.
I think it's
Trillion.
billion.
What's the answer that you got?
1,000 million billion
I
trillion.
got 400 million.
What's the trillion? Yeah, because it's
4.24 kilometers. 1 to 1,000. Oh yeah, we're multiplying by 1,000. Meters, kilometers, meters, nanometers. 1 times 10 to the 9th. It might be to the... no, I don't think it's... I don't know. I'm not good at predicting that just by looking. I don't know why. I got it to the 12th. 4.24 times 10 to the 12th. Okay, do we feel okay if I asked you to expand that number out of scientific notation? Would you be able to do it? If I asked you... yeah, but you don't add 12 zeros. You move the decimal place 12, and 2 of those are taken up right there. So you'd have 424 and then 10 zeros after that. Does that make sense? So you move the decimal and then fill in extra spots.
My calculator gives the answer.
Try the last one here on your own. Micrometers. No, millimeters to micrometers.
why is the U crying?
It's a Greek letter.
It looks like it's crying.
This is a Greek letter called for
It's so
micro. I think it's lambda. I could be wrong about that. I'm not great with my Greek alphabet.
I don't know what the things look like.
These are both smaller than a meter, right? So it's kind of tricky to feel like, well, there's not really a middleman, but I'm still going to convert to meters, then go back. because I don't want to have to try to think in my head how many micrometers are in a millimeter. You could figure it out, but I don't want to take the time to do that. So if it were me, I would take 23.3 millimeters to meter, and then I would go meters back to micrometers. That would be my path, right? I'm going to take it to the simple unit and then back, because those are the conversions that are simple on my chart. Does that make sense? Rather than try in my head to figure out how many micros are in a milli, right? You could figure that out. But rather than do that, I'm not going to. So I'm going to say 1 meter is 1,000 millimeters, and 1 meter is 1 times 10 to the 6th micrometers. Do you see what I'm saying there? I think you have the reasoning skills to figure out how many micro is in a milli, but I'm not going to waste the time to do that when my chart tells me a conversion right there. Right? I'll just do the extra step on my chart. 23.3 times 1 times 10 to the 6, and then divide by 1,000. I got 23,300 micrometers. I will tell you, when I do the math here, I always hit enter at the end of my numerator, and then I divide by whatever's on the bottom. That's just my kind of preference.
Wow.
You dropped it, Charles.
Yeah, it's Charlie.
Why are you being mean to somebody who can't?
Yeah, he's losing.
Okay, tell me what questions we have about unit conversion. I actually want to try this one first, the bottom one. Oops. And I just went ahead and moved on there.
Oh my goodness.
We'll do that one later. I want to go back. I want to go back a slide. It won't let me go back.
How many seconds are in the video? 24 times 3.
Okay, I want to try this one. Centimeters to feet. Centimeters to feet. Now, there's a couple different ways we could convert centimeters to feet. Centimeters to what? Inches, then inches to feet. Or we could go centimeters to meters, meters to feet. There's both of those conversions are on your chart, on your US to metric system chart. So you pick one. Okay, pick whatever one you're comfortable with and go from there. All right, I'm always going to start with what I know. 32 centimeters. I am going to go centimeters to inches and inches to feet. Then I go back and put my numbers in. 1 inch equals 2.54 centimeters. 1 foot equals 12 inches. So I'm going to double check my units here. I've canceled centimeters. I've canceled inches. I'm left in feet, which is what I want to be in. So if I was going to guess here, would you think this is a big number or a small number?
Very small.
It's pretty small, right? 32 centimeters is not a lot of centimeters. So we're not going to have thousands of feet here, right? It's going to be a pretty small number. When I do the math here, I multiply across the whole top, which is just times 1. So I don't need to do that. When I do this in my calculator, I'm going to divide by the whole bottom. So I'm going to take 32, divide by 2.54, divide by 12. If you do 2.54 times 12, you have to put that in parentheses, right? Because your calculator is going to do order of operations correctly. So I go 32, divide by 2.54, divide by 12, since they're both on the bottom. And I get 1.049. So I'll round that up to 1.05 feet. So if you're going to do 2.54 times 12, that would need to go in parentheses. Okay. 1.0498, blah, 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 blah. So I rounded up to 1.05. So I'll tell you what I really should do. Honestly, if I was doing better, I would have rounded it to 2 sig figs, since that's what I started with. So if I was going to round this to 2 sig figs, it technically would round up 1.049. I don't know. I might round down, because I'd be rounding twice if I did that. So I'll just call it that. I don't really care. 1.1 feet. So when there's 2 things here on the bottom, I just go divide by, right? You'll hear me say it a lot. Multiply across the whole top, divide by the whole bottom. So that just means I'm going to divide by whatever is on the bottom. That's easier for me than using parentheses and multiplication and all that stuff. I just divide by. Okay? Yep, you got to work your way through. Days to what? Okay, days to hours to minutes to seconds.
24 point something around.
True, it's not exact.
I think.
No, the leap year accounts for that extra quarter.
Yeah, it is exact.
Let's go. So it is exact.
Yeah.
We're good.
Oops, sorry.
31,620,000.
366 days. 1 day to 24 hours. 1 hour to 60 minutes. 1 minute to 60 seconds. It comes out to be 29 million or 2,900,000,000. I don't know. It's something like that. 3,190,000 something. I don't know.
It's 300. It's 30 billion.
330 billion.
No, 30.
No, it is not.
30 billion.
31 million.
31 billion.
31 million.
Yes, 31 million.
31 million what?
Oh yeah, 31 million.
620,000.
620.
Oh, I put an extra
400.
All right, yeah, that's what I was going to say.
That seems really small.
That's what I was thinking of.
500.
Tramp, you know what the fuck that is?
That might be in like a month.
Tramp.
No, that's minutes. 525,600.
Yeah, you're right. It
I
is
know.
minutes.
I
That's
think
right.
it's minutes in a month.
I got
That's
it.
It's like
It says, what data would you need to estimate the money you would need to spend on gas from your drive from New York to Los Angeles? Provide estimates of values and a simple calculation. So I want you to get into group with your partner there. So it looks like we're going to work out. So Esmeralda, grab a partner. You guys back here, grab a partner. And I want you to use this estimation of what you know, how many miles it might be, how much gas is right now, all that kind of stuff. I want you to come up with a dollar amount of how much it's going to take for you to drive from New York to Los Angeles. So you got to estimate some things like mileage, like how much miles per miles per gallon your car might get, all that kind of stuff you got to take into account. Okay? So I want you to get with a partner. Esmeralda, are you with Josh? Do you need a partner? Okay, who's your partner? Isaac. Okay, Luke, you and Esmeralda are going to work together, okay? You guys are good working together? Okay, everybody else good? No. There's three scales on which you can measure temperature. What's the one that we use? Fahrenheit. And does anyone else use Fahrenheit?
One of them.
What other country? Who is it?
No, I just know that there's
I
like,
think it starts with a
It's like
I
Vietnam.
don't know.
yeah,
I don't know.
something like that.
I don't even know the answer to that.
Belgium.
Okay,
I know there's
in science, what do you think we should use? Kelvin or Celsius. I think either are acceptable. They have a scale that works to convert with them really easily. So here's your temperature conversion from Kelvin to Celsius. Okay, and actually I'm going to get rid of this 0.15 because I just don't need it. Okay, so when we need to convert from Celsius to Kelvin, Celsius plus 273 is going to give us our value in Kelvin. Okay, that's on your printout, but I erased that 0.15 at the end of there because I just don't need it to be that exact, okay? So if I want to convert my Celsius temperature into Kelvin, I'm going to take my Celsius temperature plus 273. So Kelvin and Celsius increase at the same rate. If it goes up 1 degree Celsius, it also goes up 1 Kelvin. That's not true for Celsius and Fahrenheit. Right? If Celsius goes up 1 degree, it does not mean that Fahrenheit has also gone up 1 degree. They have a crazy conversion that's shown right down here. If I want to convert from Fahrenheit to Celsius, I have to do that equation, which, why would I? Okay, why would I want to do that? Okay, so we don't even measure our temperatures in here in Fahrenheit because I don't want to do the conversion, okay? But that's what it is in case you would need it. If I need to go back from Kelvin to end up in Celsius, I would take Kelvin minus 273, and that would give me my temperature in degrees Celsius. Okay? So tell me, what is it in Kelvin? What is, if Celsius is 0 degrees, what's that temperature in Kelvin? 273 Kelvin. Okay? What would my temperature be if it was 0 Kelvin? What is it in Celsius? Negative 273. Now, do you know what that's called? Do you know what 0 Kelvin is called?
It's like absolute something.
Yep.
Absolute zero?
Yep. Absolute 0. And do you know what happens at absolute 0?
Nothing. No, I don't know.
Life ceases to exist at absolute 0 because no molecules have any energy left, right? All the energy, it's so cold, nothing can move. Molecules can't move. Like, we're donezo at that point, okay?
Anywhere, anytime.
Not that I know of.
Has it
I
ever
don't know.
happened? Like,
Can you,
are
like, you
there
can-
places
No.
where that happens?
No.
Even in our
We
solar
like
system?
you
I don't know about solar system. I don't know. In a lab setting, I think they've got close. I don't know if they've gotten all the way there, but in a lab setting, it'd be, you'd have to be in a vacuum. You'd have to be all that. I mean, you'd have to be crazy. If we want both of these values to be the same, we're going to replace them just with a single variable. So now we're at x equals x minus 32 times 5 over 9. Now I want you to solve for x. Does that make it simpler?